Hello everyone, my name is Muhammad Azhad bin Zuraimi and my supervisor is Dr. Fadlan Hafiz Helmi bin Kamaruzaman. We are from University Technology Mara Shah Alam, and today we want to present vehicle detection and tracking using YOLO and DeepSORT for 11 series of IEEE Symposium in Computational Intelligence and Application 2021. This will be our outline for this video. We will start from the introduction, then problem statement, following to objective. After that, proposed methodology, then result. Lastly, we will talk about the conclusion. Okay, let's introduce my project. Uh, Using deep learning to be implemented for vehicle detection used in traffic management. Using a TensorFlow, which is a platform for machine learning, and you only look once. YOLO, which is object detection algorithm for real-time vehicle detection. DeepSORT framework to help counting the number of vehicles passed in a video effectively. YOLO V4, which had achieved a state-of-the-art result with 82.08% average precision at VP, using the custom dataset at the real-time speed at around 14 frames per second on GTX 1616 Ti. So, what is the problem statement of this project? The most valuable data in solvent traffic is how much number of vehicles in certain time in specific location. So, to calculate the number of vehicles passed in certain areas is troublesome and not efficient with human eyes. Human also cannot evaluate every monitor at the same time and cannot focus efficiently all the time, whereas there were few types of vehicles such as motorcycle, car, bus and truck, which made it difficult to classify and count for human. Next is what objective is this project? This project is to build an approachable intelligent traffic surveillance system to help humans attain intelligent traffic management. This system firstly is to detect vehicle in a video and classify it. System then count the number of vehicles passed through a certain line in a video. Lastly, system save the altered with altered information video which had performance review in frame per second and vehicle count visible in the video. Then we will evaluate and discuss which model YOLO is the best. This section is about a methodology. In the picture, we can see the methodology of this project. We will talk more about it in the next pages. Firstly, user need to do installation of software and dependencies. User need to research and learn the software and dependencies need and how to run the approachable intelligent traffic surveillance system. Next is using the git bash to run the bash shell command in Windows platform. The user also need hack experience with Python to learn how and do code combining machine learning, deep sort algorithm, FPS meter code, line bar counting vehicle code, and heat map vehicles movement to perform this project as vehicle detection system. Next step, we collect images. We collect vehicle images with different types, which are cars, trucks, bus, and motorcycle to train dataset. There were 3 images dataset must be unique to each other, which are training dataset, validation dataset, and test dataset. The ratio used in training dataset is 70% and validation set is 30%. The test dataset just a few because we mostly use a video as a test dataset. To collect these images, we're using the OID V4 toolkit to download datasets from Google Images. After we collect images, we then need to labeling and classifying the vehicle images dataset in TXT file with YOLO V4 format. In the TXT file, the object number and object coordinate of the related image must be in line like as object class, X axis, Y axis with had to be in the YOLO V4 format, like in the picture notepad. Then we need to train the model. We are using the Google Colab to train model YOLO faster with powerful GPU. Using Colab from the AI guys code in GitHub make it easier and organized. We just need to follow instruction and understand the flow of the coding. The training will be run in the Colab for several hours. When we train, we can see in the graph chart left side in this picture is a YOLO v4 tiny model example when we train. At the 2000 iteration, the model start overfitting because the current average loss not decreasing and in the precision of the models increasing slowly. Overfitting refers to a model that models the training data too well. It will negatively impact the performance. So to overcome this problem, short increasing the number of images in training dataset in the future train. Later, after code of Python combining machine learning, DeepSORT algorithm, FPS meter code, line bar counting vehicle code, and heat map vehicle movement to perform this project as vehicle detection system is done, it then need to run in using Git bash. The user need to enter the specific code to the Git bash, such as, for example, convert .NET back to TensorFlow model or run YOLO v4 DeepSORT object tracker on video or webcam in the picture notepad given. Following, it then will process in the Python. It consists the main algorithm in the system which process such as the setting of DeepSORT, frame by frame extract, what object to be detected, searching for region of interest, defining confidence score to be classified and boxing, filtering class to be detected, the performance of the system in frame per second, and counting the vehicle pass if pass line of interest. After it being processed in the Python, the system will then output as a video type in the specific place according to the user input. The result of the video will have the boundary box. If vehicle is detected in each frame, the FPS on the top left side on the video, and the line of interest to calculate the vehicle pass through key. This section will talk about the result of this project. The result will be the dataset download, web file models, mean average precision of the models, and the performance of the models. The dataset download using the OID toolkit, which consists of 7,319 images for training dataset and 750 images for validation dataset, for example in the pictures. The result of the model that has been trained, it will save in the WAG file. On the right side shows the table of the different WAG files that have been trained to evaluate which YOLO model would be the best suitable for the system. I can see that the vanilla YOLO have the bigger size than the tiny YOLO. Next, we will evaluate the average precision of the model. The higher the mean average precision, the accurate the model is. The different detection model, class, and challenge used to evaluate mean average precision and the validation will affect the accuracy and the speed of the model. YOLO v4 had the highest mean average precision with 82.08 from custom dataset validation than other models from the table on the right side. Lastly, we will measure the performance of the model. Use can be measured using the frame per second from the video processed by the model. In the graph, we can see that model tiny YOLO had a faster performance than the vanilla YOLO. YOLO v3 also is faster than YOLO v4 because YOLO v4 is complexity in process the parameter to improve accuracy impact the performance. Let's see video output sample. This is the equation for evaluation of this sample video. In the YOLO v4 model, we get total count of 7 vehicle pass, which is 100% true with no false positive and no false negative and performance of 14 frames per second. While YOLO v4 tiny get total count of 7 vehicle pass, which is 100% true with no false positive and no false negative and performance of 40 frames per second. YOLO v3 model get total count of 8 vehicle pass, which is 85% true with 1 false positive and no false negative and performance of 17 frames per second. Last model, YOLO v3 tiny, get total count of 6 vehicle pass, which is 85% true with no false positive and 1 false negative and performance of 53 frames per second. In summary, from the result obtained in this project, it is the best to use YOLO v4 model than previous model YOLO v3. If the system wants the highest accuracy with acceptable speed, which that got achieved at 82.08% mean average precision at 0.5, higher 22% than previous model in mean average precision at 0.5. For faster model and with less impact in accuracy, it's best to use YOLO before tiny model, which can achieve 76.14% mean average precision at 0.5, higher 10% more mean average precision at 0.5 than YOLO V3 tiny, with performance of speed as 40 frames per second using GTX 1616 Ti. This will be the reference for our project. That's all. Thank you.